Today we are going to discuss one interesting topic about the philosophy of artificial intelligence. If to be exact, our discussion topic is weak AI and strong AI. The distinction between weak AI and strong AI represents one of the central conceptual and philosophical debates in the philosophy of artificial intelligence. The term were popularized by John Searle to differentiate between two fundamentally different interpretations of what AI systems can and cannot achieve. Weak AI refers to the view that artificial intelligence is a tool for simulating intelligent behavior rather than possessing genuine understanding of consciousness. In this view, AI systems are designed to model aspects of human cognition, such as language processing, perception, or reasoning, without implying that these systems have minds, beliefs, or intentions of their own. Weak AI treats intelligence as an instrumental function valuable for its practical applications in problem solving, data analysis, and design support. Strong AI, on the other hand, claims that a sufficiently sophisticated artificial system could actually possess a mind in the same sense that humans do, that it could have consciousness, intentionality, and understanding. Proponents of strong AI, such as Marvin Minsky and later advocates of artificial general intelligence, argue that intelligence is a computational process that can, in principle, be realized in any physical substrate capable of performing the right functional operation. If cognition is essentially information processing, then there is no reason to believe that biological neurons are uniquely capable of supporting it. And one interesting subtopic in this context is about Searle's critique and the Chinese room argument. John Searle famously challenged strong AI through its Chinese room argument in 1980, which illustrates the difference between syntax and semantics. In this thought experiment, Searle imagines a person inside a room following instructions for manipulating Chinese symbols without understanding their meaning. To outside observers, the room appears to understand Chinese, but internally, no genuine comprehension occurs. For Searle, this demonstrates that symbol manipulation alone does not constitute understanding. Computers, no matter how sophisticated, process symbols syntactically but lack the semantic and intentional dimensions of human cognition. This argument has profound implications for the philosophy of mind and the ethics of AI. If strong AI is unattainable, then even the most advanced AI systems, including those interfacing with human brains, remain tools rather than thinking beings. Yet, if strong AI is possible, then artificial systems might one day achieve moral and cognitive status comparable to humans, forcing us to reconsider the nature of consciousness, responsibility, and rights. And our second subtopic in this context is about weak and strong AI in the context of BCIs. The emergence of brain-computer interfaces, that's BCIs, complicates the weak and strong AI distinction. Traditional weak AI systems are external, computers or algorithms that simulate thought. BCIs, however, merge these systems directly with human neural processes, creating hybrid intelligence. In such hybrid systems, the artificial component does not merely simulate cognition, but actively participates in it. For example, a memory-enhancing BCI might supplement a person's recall ability by providing computational support that feels internally generated. This raises a key philosophical question. Does this hybrid system remain a case of big AI assisting a biological mind, or does it constitute a step toward strong AI embedded within a biological substrate? Some philosophers argue that BCIs bring forth a graded conception of intelligence, where the line between weak and strong AI becomes blurred. According to Clark, when AI systems are functionally integrated into human cognition, so that information flows seamlessly between brain and machine, intelligence should be seen as distributed across both domains. This extended intelligence challenges Searle's sharp dichotomy by suggesting that consciousness and understanding might emerge from interactive networks rather than isolated agents. And our next subtopic in this context is about ethical and ontological implications. The debate weak and strong AI also shapes the ethical discourse around BCIs and cognitive enhancement. If BCIs remain in the domain of weak AI, they can be understood as instruments, extensions of human agency. But if they evolve toward strong AI, incorporating autonomous decision making and adaptive self learning, they may develop quasi agential characteristics that challenge our concepts of moral responsibility. Who would be accountable for actions performed through a semi autonomous neural interface, the human user or the AI model? Furthermore, strong AI raises ontological questions about the nature of consciousness. Can artificial neural networks or hybrid brain machine systems achieve subjective experience? Neuroscientific materialists might argue that consciousness is an emergent property of sufficiently complex information processing. In contrast, phenomenologists and dualists maintain that subjective experience involves an irreducible first-person dimension that computation alone cannot capture. In the context of BCIs, this tension becomes particularly pressing. If a person's perceptual and cognitive experience is partially generated by artificial computation, does that computation contribute to consciousness or merely influence its content? The answer to this question may determine whether future AI neural integrations remain tools of thought, weak AI, or become participants in thought, strong AI. That's all for today's discussion. Thank you for watching. If you have got any questions, you can address them in the section of comments. Okay, see you later.